Welcome back to the fundamentals of advanced manufacturing. Now that we looked at the high level, sort of the macrocosm above, what we want to do is we want to take it way zoomed in, and we want to look at the microcosm below. This is where we get material sciencey when it comes to manufacturing, and we focus on the structure, the very, very teeny tiny structure, the atomic structure up to the crystal structure, up into the microstructure, which that gives us our properties, that allows us to build structures. You ready? Let's check it out. So first off, we want to recall that we're focused on metals in this course. And interestingly, we don't really find them in nature. Outside of silver and gold, we don't find like large chunks, right? There's a bit of an alchemical story and some capitalist lore there as well, but we're going to focus on the materialist point of view today. And that starts really at the atomic level. We don't really mess with subatomic when we're talking about real practical level structures in today's business value creation and manufacturing worlds. But we do go down to the atom level sometimes. And the way that we assemble the atoms is into little cubic structures of atoms. And then what we do with those little cubic structures of atoms is we assemble them into larger structures of cubic little atoms. And when they're all aligned along the same direction, even though sometimes there's some imperfections and they're not all aligned along the same direction, when they're mostly aligned along the same direction, those tend to constitute a single crystal structure. And that micro level structure, we call that a grain. And these grains that are made up of a set of crystal structures all strung together into a single crystal or a grain then come together to form more complex polycrystal materials that we actually make stuff with. So now that we can visualize the atomic structure moving into a crystal system at the nanostructure level, and then those crystal systems combining into grains or grain structures, now we want to see if we can visualize how those grain structures actually make up larger parts, like tensile test specimens or like pieces of sheet steel. If you zoomed in on a classic tensile test specimen, you would find grains that were roughly equally sized in 3 dimensions. That's something called being equiaxed, sort of equal axes. Each of the grains in 3D is more or less the same size and more or less oriented kind of in a general direction outward, more spherical than anything else. And when you have grains like this, you have a stronger material pulled from any direction. So this is very useful. It's also very useful to think of how grains might change their shape depending on how you process a material, how you manufacture it. So if you roll out some sheet steel, you might actually roll each of the grains inside of the material. So instead of having these perfectly equiaxis grains, what you end up with is you end up with these rolled out grains, just like you would roll some oats or just like you would roll out some dough if you were doing some baking. And what you get is you get a structure that is stronger in one direction than in the other. And so this is useful sometimes, and this needs to be kept in mind at all times. So if we can visualize going from the atom to the crystal structure, to the nanostructure, to the microstructure, to the component level, that's exactly where we want to be.